Hey guys, it's Mr. Senior. We're going to get started with today's lesson. So today what we're going to be doing is solving volume from a real world context. So today I can calculate volume from real world context. So look at this picture, pause your video and kind of describe this figure in your head. You can write some things down. So when you look at this video, a couple things you should notice is first, it's a rectangular prism, and then also that it is three-dimensional. So because it's three-dimensional, that means it has a length, a width, and a height. So volume is always the amount of space that the three-dimensional figure occupies. So that's the length, the width, and the height. It's that whole entire space. So it's like the amount of stuff that can go inside of something. The rectangular prism is what we're calculating volume for today. It's a three-dimensional solid shape, which has 6 faces that are all rectangles. It must have the length, the width, and the height. Okay, so if you look at the non-example, we'll see it only has length and width. It's two-dimensional. For a two-dimensional figure, we cannot go and find volume. All right, so first thing, Patrick has a moving box that is 3 feet wide by 3 feet long and 4 feet high. What is the volume of the box? So what I'm going to do here is I'm going to draw myself a picture. I know we're working with a rectangular prism, so I'm going to draw a model that I can use to help me understand my problem. So I know it's 3 feet wide, I know it's 3 feet long, I know it's 4 feet high. Now the next thing I'm going to do is multiply my length, my width, and my height together. So my volume is equal to my length of 3 times 3 times the height of 4, which comes out to be 36. The last thing we need to do here is we need to make sure we write it as units cubed. Our units is feet. Feet cubed. Our answer is 36 feet cubed. Go ahead and work on the one on the right. Pause your video and then unpause it when you're done. You should have got a volume of 60 feet cubed. So if you just have 60 feet, you're not entirely correct. Your multiplication, everything was correct, but you need to make sure you have your units and have them cubed. All right, so our next one, a cereal box. So I have a cereal box. I'm going to draw me a model of a cereal box. Anytime I'm doing geometry stuff, I like to draw a model to help me visualize. So it's 12 inches tall, 4 inches wide, and 8 inches long. What is the box's volume? I'm going to go and multiply all these. The volume is equal to 12 times 8 times 4. Remember, this is a standard for your calculator. 12 times 8 times 4 is equal to 384 inches cubed. So all I'm doing is I'm creating a model. I am labeling its sides, and then I am multiplying them all together, and I got 384 inches cubed. Go ahead and pause your video, work on the one on the right. You should have 12 feet squared. All right, so now we have a rectangular horse trough that is 48 inches long, 20 inches wide, and 15 inches tall. So I'm going to draw a model. It's 48 inches long, 20 inches wide, 15 inches tall. Volume is equal to length times width times height. So in my calculator, I'm going to do 48 times 20 times 15, and I'm going to get my volume is equal to 14,400 inches cubed. This is the maximum amount the water can, or a maximum amount of water it can hold. It's the amount of water that can go inside of this. Go ahead and pause your video, work on the one on the right. You should have got 1,728 inches cubed. All right, so moving on. Jake bought a flat rate box in the post office to send a gift to his grandma for her birthday. The dimensions of the medium-sized box are 14 inches by 12 inches by 3.5 inches. What is the volume of the largest gift he can send to his mother? So how much can he actually put in here? So if I have this box, I'm going to draw a box to help me out. It's 14 inches by 12 inches by 3.5 inches. What is the maximum volume he can hold here? I'm going to take the volume is equal to 14 times 12 times 3.5. 14 times 12 times 3.5 is equal to 588. So volume is equal to 588 inches cubed. Go ahead and pause your video, work on the one on the right. And you would have also got 588 because our dimensions were the exact same here. All right, so our last variation. This was a quick lesson for you guys today. So our last variation, Laura's having a planter box built for her. It's 4 feet long, 2 feet wide, and 1 foot tall. If she wants to fill it halfway, how much dirt will she need? So the key thing here is she wants to fill this halfway, meaning she doesn't want to fill it all the way up. So we don't need the whole entire volume. I'm still going to go and solve my volume normally. So I know it's a 4 by 2 by 1. So my volume is equal to 4 times 2 times 1. My volume of this whole entire thing is 8. So the volume of the whole entire planter box would be 8 cubic feet. However, I want half of this. I don't want the whole thing, I want half. So I'm then going to go and multiply this times 1/2 to get a volume of 4 feet cubed. My volume would be 4 feet cubed. Go ahead and pause your video, work on the one on the right. Pay attention to the amount that it wants to be filled on this one. So your original volume would have been 36, then multiplying that times the 3/4 that it wants, you would have ended up getting 27 feet cubed for your volume. I guess that's all we have for you today. Go ahead and work on your independent practice. If you have questions, if you're confused, make sure you're joining our tutorial time. Hope you guys have a great day, and we will see you then.